Hello everyone, welcome back to Coder's project. In today's video, we're going to be solving the binary tree in-order traversal. So we're given a root of the binary tree. We need to return the in-order traversal of its nodes values. So if this is the input, we first go ahead and construct our tree. 1, and then we have a null for our left subtree, and then 2, and then 3. So our output is going to be first we traverse and read through our left subtree, which is null. So we go ahead and pop the node, root node, and then we go ahead and explore the right subtree, and then start from the bottom and then go towards the top. So it's going to print out 1, 3, and 2. So instead of doing it recursively, we're going to do this iteratively. So it's going to be more efficient, and it's going to have time complexity of big O of n, where n is the number of nodes on the tree. So what I'm going to first do is I'm going to initialize a stack and a result list. So stack is basically going to store our temporary nodes as we traverse, and then result is going to store our final in-order traversed binary search tree. And then let's get into a loop now. So while there are nodes in the stack, or the root is a null, we can basically process. So it's while stack or root. We'll go ahead and push all the left nodes onto the stack. So while root stack dot append root, and then root is equal to root dot left. So we're going as far left as possible by pushing all the left nodes onto the stack. Think of it like exploring the left branch of the tree before you process the node itself. And now we can go ahead and process the node. Once we have hit a null, we go ahead and pop the top node from the stack. So our root is equal to stack.pop. And then that's our current node which we need to process. So we're going to add the value to the result list. So result.append root.val. All right, now we're going to move to the right subtree. So I'm going to set root to root.right. And then finally, once all the nodes have been processed, we're going to return the resulting list containing the in-order traversal. So let's just return our result. This is going to have a time complexity of O of n, where n is the number of nodes in the tree. Each node is visited exactly once. And then our space complexity is going to be O of h, where h is the height of the tree. Let's go ahead and run this. Alright, all our test cases are passed, and that's it. Now we have a solid understanding of how to perform an iterative in-order traversal of a binary search tree. It's a great technique to add to your problem-solving toolbox. If you found this helpful, don't forget to like the video, subscribe to my channel, and let me know in the comments what are the topics you'd like to see. Thank you for watching. I'll see you in the next one.